our objective today is that you will be writing and graphing inequalities. You will translate the inequalities from words to symbols. Right now, we're in the process of creating a foldable that, if you weren't in here a minute ago, I said you're going to want to hang on to. That you want to be able to, you definitely want to understand what you're creating so that you may use it in your future. Let's see if I get it.
Click later really fast because your computer's going to restart in 40 seconds.
Go away. All right. At the top, we have taken this piece of paper and we folded it in half. And then we folded it into fourths. Autofocus. Got it. On the top of the paper, we have written inequality symbols. Okay. Then in each of the fourths, all we're doing on the very front of it is we are writing the symbols. We have the symbol for less than, greater than, less than or equal to, and greater than or equal to. That's on the front. Okay. Then take your scissors, because now you have a line there. You're going to open it. I only want to cut the top half, not into the bottom. And I'm not going to cut it all the way up that it goes apart. But I want to be able to lift the flap. Such as, I've got my flaps here and I want to be able to lift them to see what's underneath for each of my sections. Okay? We understanding so far? So cut your, be able to use this and flip it up. Does anybody need?
I need a pair just for me.
I got 3 pair. Make sure that I get mine back, okay?
Mrs. Heston's a dingbat.
No biggie. Okay, does everybody have this part done? Okay. Now then, we're going to take our paper and we're going to fold it over to the back. Let's get some important definitions down on the back. Escape. Go back to here. On the back of it, first of all, what do you know? What is an inequality? What is an inequality? Very good. An inequality is a math sentence that compares expressions. Usually, especially with where we're at in math right now, it will compare 2 expressions. But as you advance in math, you may find that it compares more than 2. Okay? But at least 2 expressions are being compared using an inequality. We're just going to get our terminology down so that once we get it down, then as we talk about it, it will become clearer for you. Okay? The next, and these are all being written on the back side, so you've got them. Okay? The next one would be the solution. of an inequality. And it is any value that makes the inequality true. So the value that makes an inequality true. With inequalities, though, normally you don't have one solution. Because if I said x is greater than 5, is there only one number that would work? No, there's multiple. Okay? So we call that the solution set. The solution set is the set of all solutions of an inequality. Okay. There's never just one solution to an inequality. There's always a set. Because if there was only one solution, it would be an equality, not inequality. Okay? You've already done some graphing of inequalities. Just x is less than 5 or x is greater than 5. Am I correct?
Yeah.
While I was gone, you did some graphing?
Yeah.
Okay. So the graph, in order, and this is something just again, making sure, when it comes to graphing and inequality, the graph of an inequality shows all possible solutions. Okay, on the graph of an inequality, you can have an open circle or a closed circle. What's the difference? When do we use an open versus when do we use the closed? Aaron?
When it's greater than, I mean, when it's like, what is it? When it's equal to. Yeah, less than or equal to. Or just, with the underlying meaning, that's the meaning.
Has nothing to do with the way the inequality points.
It's the,
Has nothing to do with there being a line under it. When do I use an open circle?
When you use an open circle, it's the number is not included.
There we go. An open circle says the number is not a solution. Why do I use a closed circle? What does it signify? What's it going to signify, Caden?
When it can be part of the solution.
The number is a solution. Okay? And there's something else that the graph will always have. We were talking about an inequality. And that would be an arrow to the left or right. Shows that the graph continues. What we're getting down right now is just the basics. That is the most important in this chapter, to be able to do what we got to do. Hey, you have a good weekend? How many's starting to think about that turkey dinner coming up? Anybody already have one?
We have ham.
I had one.
Like 2 for last.
Okay. Does everybody have this down? Okay, we're going to move on. Let's go back to the other side of our inequality. Go back to the front side. Going to lift your flap. This symbol, voices are off now. I'm starting out with the, what did you just say, Kenai? Less than symbol. I'm going to fold my flap up and just make a note to myself. Is less than. Ooh, sorry. I do this and maybe I'm underneath that first flap, my less than flap, and the flap, it means is less than, or it might say, another way that it may be expressed is fewer than. Those are some key words for you to help you identify how to take the words and turn them into symbols. If you read a story problem and it says is less than, then you know you're looking at the less than symbol. Is fewer than, it's the less than symbol. And again, I just made a note on this side that I would graph is less than with an open circle or an open dot. Again, just making sure. And if you notice my bullets, I use the open. Trying to get it through.
Wow.
Trying to get it. There's a reason why I did that. Not just because I wanted to be.
Yeah, I was like, those are weird.
That's why. The symbol next to it is greater than. So I'm going to pull up the is greater than. And you would hear it, the terminology would be is greater than or is more than. And again, it's graphed with an open circle or an open dot. Some people call it circles, some people call it dots. That open dot tells you that the number is not a part of the solution. Does everybody have these two? At least have the first ones where I can slide over. Okay, the next symbol we had is less than or equal to. Our circle is closed. You may read something that says 5 is less than or equal to 6. Closed dot. 5 is at most. The term at most tells you that my inequality symbol is less than or equal to. Meaning, I could be, at most I could have 5 apples, but I could have less. That's why the less than or equal to. I can have no more than $5 on the field trip. That one's a pretty easy one to understand. You get there with 6 and you've got more than you're supposed to have. It's not going to work. We graph it with a solid dot or a solid circle. I'm going to slide one more where we've still got. Our final one is greater than or equal to. greater than or equal to is at least. So in order to go to the movies, you must have at least $10. If you don't have at least $10, you don't get to go. So at least. Or the statement, the cost is no less than $10. Again, you know you have to have 10. And you graph it with a solid dot or a solid circle, whatever you want to call it. Hit that door since they changed it. I'd rather unlock it. I'm tired of hearing about Byron.
Yeah.
I don't know. I'm the good person. Yeah.
Okay, now let me get that off. Let's take this and let's see what we can do with this. You may want a piece of paper to take any additional notes, because this is all that can be on what you've got. In order for you to be able to use it in the future, that's it. You can't be putting more stuff on it than what we've already got on it, okay? Unless I tell you differently. Fair enough? What if I told you, because one of our goals is to change the words into symbols, what if I said, somebody change that statement, x is at most -10. You're going to change that statement into symbols. And you can use your little thing that you just made. I mean, that's why we made it. At most, -10. Okay, no, finish it out. You just put a symbol there. You got to finish out the whole statement, buddy. There we go. Thank you, sir. Do you agree with him? Mm-hmm. At most says it can't go above it. -10 is as far as you can go. Okay? What if I said twice a number y is more than -5/2? Twice a number y is more than, I say -5/2? Yep. Turn this sentence into a mathematical statement using symbols. Twice a number y is more than -5/2. Nice job. Class, what do you think? 2y is greater than -5/2. Is she correct? Okay. Let's see. Somebody now if we can take the words and put them into symbols, we should be able to take the symbols and put them into words. So somebody tell me, what would the sentence, or how could the sentence read that stands for what I've got there? Using your little cue words, How can I turn that into a sentence? Landon,
X is fewer than -1.
okay? Or a number X is fewer than -1. That works. Because you got to say, otherwise you're looking at X the letter, right? So a number, oops, is fewer than -1. Good job. Will that work? What do you think? Is this something that you think you'll be able to do without any problem? Fist of 5. Show me what you got. Okay. What if I said, okay, now we can change them in. What if I said, let's find out if I gave you this problem. Okay, x plus 12 is greater than 7. Okay, the sum of a number x and 12 is more than 7. Would that be a true statement? Okay, what if I said, tell me whether -5 is part of that solution? What are you going to do? I want to know, is -5 part of the solution, and how would you determine that? How are you going to determine it?
It wouldn't be because if you add 12 and -5 it would be 7, and 7 can't be greater than 7 because it's the same number.
Absolutely correct. You would substitute what they say the x could be into the mathematical expression, and you'd solve. Well, -5 plus 12 is 7. And is 7 greater than 7? No, it is not. It's not a solution. And so that's why I'm putting the slash through the greater than symbol, meaning it is not a true statement. It is not a solution. So in this case, this would be a false statement. Okay? Not part of the solution. Okay, what about you guys doing this one? And you'll give me thumbs up yes and thumbs down no. Let's try this one. 1 minus 2p is less than or equal to -9. I'm going to write it up here. 1 minus 2p less than or equal to -9, and I'm going to tell you that the solution we're checking is the -5 again. Is -5 a part of the solution? Does it make the statement true? So get it done, don't blurt. When you finish it, put one hand on your head. I know you got it done. No logs today. If you believe that -5 is a solution, stand up. Okay. Some of you disagree. Have a seat, folks. Majority says -5 is the solution. Well, let's test it. 1 minus 2 times -5 less than or equal to -9. That's a 5. Oops. Doesn't look like a 5. Now it looks better, right? Well, 2 times -5 is -10. Am I correct? Add opposite. 1 plus 10 is 11, and 11 is not less than or equal to negative 10.
I don't know. I had it written out like that, but I looked at it. I
Ah.
had 11.
Or you can just simplify it to
Not a true statement. Okay, I need voices off, please.
I did the 2 minus -5, and that's -10.
Right.
1 minus
1 minus negative 10 is still 1 plus 10. Therefore, it is not a true statement. You see, we're still using all of our integer rules. Yes.
I just didn't spend a time on thinking that one part. I was just thinking 1 minus 10, so that's where you got confused.
I know.
So I was just going too fast, I think.
Slow down. Yes.
simplify it and then look at it. And then instead of having it like so, then -1 is -2 is less than or equal to -9, which is divide by -2 instead of
Okay. She's saying I could have just simplified the statement by doing the whole solve for P, which you could, and I agree with that completely. For me, if I've got a number and I just want to know if it's part of it, I'm going to substitute it. I'm just going to substitute it rather than having to simplify. Either way is acceptable, okay? Either way is acceptable. But you do have to be careful because all of the integer rules apply, all right? Now, what if we take the one that we just did? Let's take the one we did. Can I graph? No, I don't want to do that yet. We are going to, but not yet. Graphing inequalities, is that an issue at all? If I said x less than -1, are you familiar with, I've got my graph and it's really not a very straight one, but it'll work. And am I going to do an open circle or a closed? Open circle. And then I bring my arrow and that's graphed and I'm done. Okay, the graphing part, is it going to be a problem? Okay, I didn't think so. What if I said z is greater than or equal to 4? Okay, again, I've got the graph. 0, I'm going to run with 4 right there, -4. Open or closed circle, and where do I put it? Closed circle where? At +4, okay? And then what do I do with this? I got a closed circle. Which way is the arrow going to go? Left or right? Left or right for the arrow, Paige? Right. Good.
If your variable's on the left, it always points to the whichever way it's going.
If the variable's on the left,
Yeah.
yes. That is very true. Okay, what about, I think that's it. Let's see. Checking solutions, we've graphed. Yeah, how about an assignment? Yeah. Okay, your assignment. Your assignment is, where's mine? There it is. Go into the textbook, please. Textbook page 128, 129, which I'm talking about the packet that I gave you. 1 to 3, 6 through 20 even, and 21 through 27 odd.